All right, this says gradient of tangents and normal. Now, a tangent to a curve is a straight line that touches the curve at a single point. So, for example, in a diagram to the left, the tangent will be that blue line, the blue line that has tangent at the end of it. It is a straight line that touches the curve at a single point. It doesn't cut the curve, it just touches it. Now, the point where it touches the curve, you could call that the point of contact or the point of tangency. So this is called the point of contact or the point of tangency. That's where the point, where the curve, where the tangent touches the curve. Now, the normal to the curve at the point of contact is at right angles to the tangent. The normal to the curve at the point of contact is at right angles to the tangent. Stay with me. Now, the gradient of a curve at the point xy, dy by dx, that's the gradient of the curve at the point xy, is equal to the gradient of the tangent at the point xy. So the gradient of the curve, and you get the gradient of the curve from dy by dx, is equal to the gradient of the tangent to the curve at the same point. So the gradient of the tangent is equal to dy by dx, now, and the gradient of the tangent multiplied by the gradient of the normal is equal to -1. So that is coming from our knowledge of coordinate geometry, that the product of the gradients of perpendicular lines is -1. So that is why the gradient of the tangent multiplied by the gradient of the normal is equal to -1. And so the gradient of the normal is equal to minus.
Excuse me, sir.
Yes, go
Can you
ahead.
please repeat why you said the gradient of the tangent is equal to the times the normal is equal to -1?
Yeah, man, all I simply said was the gradient of the tangent multiplied by the gradient of the normal is -1. And then I also said that that is coming from our knowledge of coordinate geometry. In coordinate geometry, we learned that the product of the gradients of perpendicular lines is -1. The product of the gradients of perpendicular lines, and perpendicular there means at right angles to. So if two lines are at right angles to each other, the product of their gradients is -1. So therefore, the gradient of the normal is equal to -1 over the gradient of the tangent. In other words, if I have the gradient of the tangent, to get the gradient of the normal, I must invert the gradient of the tangent and change its sign. That means if I have the gradient of the tangent and I want the gradient of the normal, I must invert the gradient of the tangent and change its sign. Let's have a look at example 24. All right, so we're at example 24 is asking us to find the gradient of the tangent to the curve. So this is the curve at the point where x is equal to 0. I told you that the approach to it is the approach you would take as if you're doing a differentiation of a function of the form, that form to the right. So the first thing I would do is I would take ln for both sides. So this is ln y is equal to x minus 2 ln 2x plus 1. Tell me if you agree so far.
Yes, sir.
The power comes to the front, and the power is x minus 2 that comes to the front, and I basically take ln of both sides. Now I'm going to differentiate. On the left, I'm differentiating ln y with respect to y. If I differentiate ln y, I'm going to get 1 over y. And I have to multiply by the differential of the inside function, which is dy by dx. The inside function is y, And when I differentiate y, I'm going to get dy by dx. So that is the left. On the right hand side now I have a product. So I'm going to have to use the product rule, which is leave the first, which is x minus 2, differentiate the second. If I differentiate ln 2x plus 1, I'm going to get 2 over 2x plus 1. So that's leave the first, differentiate the second, plus differentiate the first. The first is x minus 2. When I differentiate x minus 2, we get 1. Leave the second, ln 2x plus 1. All right, so then now I have 1 over y dy by dx is equal to, so if I tidying up this, I could say it's equal to 2 into x minus 2 over 2x plus 1 plus ln 2x plus 1. So that's a different, if I'm, next I'm going to bring this y from there to here and put this in bracket. So I'm going to get dy by dx is equal to y into 2 into x minus 2 over 2x plus 1 plus ln 2x plus 1. All right, guys, you cannot be afraid of the mathematics. I mean, go where it takes you. So y is actually equal to 2x plus 1 to the x minus 2. So I'm going to put that in 2x plus 1 to the x minus 2. And this is into 2 into x minus 2 over 2x plus 1 plus ln 2x plus 1. So this is the derivative. Then I'm going to say now, what happens when x is equal to 0? dy by dx, wherever I say x, I would replace x with 0, is equal to 2 times 0 plus 1 raised to the power 0 minus 2 into 2 times 0 minus 2 over 2 times 0 plus 1 plus ln 2 times 0 plus 1. All right. So all I have to do is just don't make any mistake. Over here, this is actually going to come out to be 2 times 0 is 0. So in the bracket, all that is left is 1. 1 is raised to the power minus 2. When you raise 1 to any power, you still get back what? 1. Inside the bracket now, I have what? Minus 2 in the bracket. 2 times minus 2 is minus 4. So this is minus 4 over, we have 2 times 0 is 0 plus 1. That's over 1 plus ln 1, and ln 1 is 0. So inside the bracket, what I have is minus 4, and 1 times minus 4 is minus 4. So the gradient when x is equal to 0 is dy by dx is equal to minus 4.